Hello, my name is Ana Ricardo, and with my partners Magnus Vidi and Everardo Cruz, we're going to present the Global Shared Learning class from the class Fall 2020.
Hello everyone. I had the opportunity to participate in the Global Shared Learning class program, a collaboration between Tec de Monterrey and the University of Leicester. During this experience, we worked with students from different countries, which helped us to develop intercultural skills, share experiences about our projects, and understand the fundamentals necessary to carry them out more effectively. It was a very enriching experience, both academically and personally. It gave me the opportunity to talk to people who I would have never otherwise spoken to, and collaborate on an interesting engineering project which broadened my scope and enriched my learning.
In this part of the project, we faced different challenges while implementing the heating system logic. Our goal was to reproduce the behavior of a thermostat using a microcontroller on the Tinkercad platform. The system follows the flowchart shown here. It checks two main conditions: whether the manual override is active, and if the temperature is higher than the user-defined set point. One interesting challenge was handling the don't care state when the override is active, since it forces the boiler to stay on regardless of the temperature. This helped us to understand how to translate logical flowcharts into working microcontrollers code that manage real variables and outputs.
Okay, let's begin with our problem. For this problem, we use a simulation at Tinkercad. We use Arduino Uno as our brain. It controls everything: the temperature sensor to sense the temperature, the potentiometer to set a desired temperature, the slide switch to provide a manual override of the system no matter what temperature we set the system to, and finally the LED that simulates the heating system.
In this code, we control a simulated boiler using an LED. First, we define the pins for the LED, the override switch, the temperature sensor, and the potentiometer that sets the desired temperature. In the loop, we read the state of the switch, the ambient temperature from the sensor, and the value of the potentiometer. Then, we convert those readings into degrees Celsius and a set point between 0 and 50 Celsius. The logic is simple. If the override switch is on, or the current temperature is less than or equal to the set point, the boiler turns on. Otherwise, it turns off. Finally, we display all the values on the serial monitor to observe how the system responds in real time.
Okay, after we combine the simulation, the circuits, and the programming, we have this. This program, well, as we said before, the potentiometer sets a temperature we need to achieve. The sensor senses if the temperature is already above this or below this. If it's below, it turns on the left or the heating system. If not, it will remain turned off. Then, if we turn on the switch, no matter what temperature we set the system to, it will turn on the heating system, or in this case, the LED. At the right, we have the different information we can have from the system, and at the left, we have all the circuits.
This project allowed us to explore different ways of working and learning, broadening our perspective through cultural exchange. Although managing schedules and time differences was a challenge, thanks to globalization and today's digital tools, we were able to collaborate and successfully achieve our goals.